Isaac Newton, 1643–1727, was an English mathematician, physicist, astronomer, and author who is widely regarded as one of the most influential scientists of all time. His groundbreaking work laid the foundation for classical mechanics and the laws of motion, revolutionizing our understanding of the natural world. Early life and education. Isaac Newton was born on December 25, 1643, in Woolsthorpe, Lincolnshire, England. His father died before he was born, and his mother remarried when he was 3 years old, leaving him to be raised by his maternal grandmother. Newton attended the King's School in Grantham, where he showed exceptional aptitude in mathematics. In 1661, he enrolled at Trinity College, Cambridge, where he studied the works of prominent scientists and mathematicians of his time, including Galileo and Kepler. Newton's intellectual prowess soon became apparent, and he delved into a broad range of subjects, including mathematics, optics, and astronomy. The reflecting telescope. In 1668, while still a student, Newton designed and built the first practical reflecting telescope, known as the Newtonian telescope. Unlike refracting telescopes of the time, Newton's telescope used a curved mirror to gather and focus light. This invention marked a significant advancement in observational astronomy, allowing for clearer and more detailed observations of celestial objects. Laws of motion. Newton's most significant contributions came in the field of physics. In 1687, he published his seminal work, Philosophiae Naturalis Principia Mathematica, Mathematical Principles of Natural Philosophy. In this monumental work, Newton presented his laws of motion and the law of universal gravitation. First law of motion, law of inertia. An object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction, unless acted upon by an unbalanced external force. Second law of motion. The acceleration of an object is directly proportional to the net force acting upon it and inversely proportional to its mass. Second law of motion. The acceleration of an object is directly proportional to the net force acting upon it and inversely proportional to its mass. Third law of motion. For every action, there is an equal and opposite reaction. These laws provided a unified explanation for a wide range of physical phenomena, from the motion of planets to the behavior of objects on Earth. They laid the groundwork for classical mechanics and became the cornerstone of physics for centuries. Law of universal gravitation. In the same work, Newton introduced the law of universal gravitation, stating that every point mass attracts every other point mass in the universe with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This law explained not only the motion of celestial bodies, but also the behavior of objects on Earth. It provided a comprehensive understanding of gravitational forces, marking a pivotal moment in the history of science. Later life and achievements. Newton's influence extended beyond physics. He served as a member of the Royal Society and later became its president. In addition to his work in mathematics and physics, he made significant contributions to the field of optics. Newton conducted experiments with prisms and discovered that white light is composed of a spectrum of colors, laying the foundation for the understanding of light and color. Isaac Newton's impact on science and mathematics is immeasurable. His laws of motion and law of universal gravitation became the basis for classical physics, and his work laid the groundwork for the scientific revolution. Newton's legacy endures as a symbol of intellectual curiosity, innovation, and the power of human reasoning in unlocking the secrets of the universe. He passed away on March 20th, 1727, leaving behind a legacy that continues to shape the way we understand the natural world.